Now, of course, you can also do subtraction with the minus operator. That hopefully does not come as a big surprise. But more interestingly, you can also do a division, and that's what I want to do here. I'm dividing lucky number by 3. And if I do that, we'll see something interesting here. If I now run this program with go run first app go, we get 5 as a result here. And that might be unexpected, because 17 divided by 3 is definitely not 5. It should be 5 dot something. Here it's important to keep that type thing in mind again. And here we are working with integers, which are numbers without decimal places. So not 5 dot something, but just 5 or 10 or minus 10. And lucky number is such an integer. Even more lucky number is also an integer, because that's the value inferred here when we first create that variable. Now 3 here is also an integer. And therefore, if I divide an integer by an integer, and I want an integer here, I get an integer. And instead of the result 5 dot something, Go simply cuts off the decimal part and just gives us the integer part of the result, which is 5 here. Now, sometimes that is exactly what you want, but of course sometimes it's not. And to work around that, we need to work with other value types in addition to integers. We also need to work with so-called floats, floating point numbers, which are numbers that do have a decimal place. And the exact type is actually called float 64. There also is a float 32 type, and I'll come back to the difference in a second. For the moment, let's just call it float in general. Floats are numbers like this, numbers with decimal places. And we can now use such a float here in our calculation to get the mathematical accurate result. For that, we might want to create a new variable instead of assigning to an existing one, which is an integer, which actually will be of type float. So here we could name this new number and assign our value like this, and then use that here. However, with that alone, we won't do the trick. If I now re-execute this command, I still get 5 as a result down there. So just using a new variable wasn't enough. Instead, we now need to make it clear that this variable shouldn't be of type int, because at the moment that's inferred because we're using an int here on the right side. That's now a use case for this more verbose variable creation here. Instead of doing it like that here, we can create a new number and make it clear that we want a float 64 value here. And then we assign a value where we use lucky number and divide it by 3. And you see something interesting. As I typed lucky number, Go, this Go extension here in Visual Studio Code, automatically added this float 64 command, which is wrapped around lucky number. Because if I would type it without that, if I just type lucky number without autocompletion like that, I get an error. And the error is that we cannot use this operation here because in the end this is not a float 64 value. Instead, as we saw before, this gives us an integer. And Go is very strict about its types. An integer is a number, a float is a number, and yet they are not the same. Because floats have decimal places, integers do not. Hence, what we need to do to perform this operation is we need to convert our integer, lucky number, to a float first, and then we can divide by 3. And we do that with the float 64 command, which is a built-in command, which we execute like this, with parentheses and our integer passed between those parentheses. And this now converts lucky number, which is an integer, to the same number as a float. So simply with .0000 added after the integer number, so to say. So you could say the number 17 becomes 17.000 and so on. That's the conversion that takes place here. Now we don't need to convert 3 because if you create a value directly in the operation as I'm doing it here, Go is actually more flexible about this and then will convert this to a float behind the scenes. It just doesn't do that for an explicitly defined variable, which was defined as an integer before. For such clearly defined variables, we have to make an explicit conversion. For a number we introduce directly in the operation, this conversion is made implicitly by Go just when it needs it. But with that, we are now performing the same division operation with float values instead of integers. And therefore, if we then save this and we execute this file again, we now do get our float value here, as you can see. And that's the mathematical, more correct value. And this might seem like a lot of talking about simple math, but these are core concepts in Go. And it is especially important to understand that Go is very strict about these types and doesn't allow any random operations or a lot of automatic conversions. Instead, you have to explicit about your types and therefore then also about your conversions. And this is then how we can work with floats in addition to numbers. Just to have this comparison again, in JavaScript or Python, that would be more forgiving. Here we don't have that type strictness, and therefore in both languages we could store a value like this in some variable, which is an integer, and then just make that division. In JavaScript we don't even have the differentiation between integers and floats. There we just have a number in general, and hence it doesn't care about whether that is a float or an integer. And in Python, we theoretically have some differentiation, but still we can just use an integer in a division operation like this. And if we would execute this Python file, for example, we would get the correct result nonetheless. So JavaScript and Python are more forgiving here. Go is not. In Go, you have to be very explicit, and we have to differentiate between integers and floats. Now coming back to that float, you might remember that I said that there are float 64 values and float 32 values. Now both exist, and the difference is that float 64 values are more precise, but they also take up more space in memory. And to show you that difference, I'll create a new variable down there, default float, which I create with that shortcut with colon equal sign, which is 1.236789, and then I repeat that a couple of times like this. Now this, if I hover over it, is typically inferred to be a float 64 variable, though it will depend on the underlying machine and operating system. So if you want to be sure that it's float 64, you want to use that longer definition here without colon equal sign, just like this, because then you explicitly set the type. And now I'll copy that line of code and do the same with float 32 and name this small float. And then I'll just copy that print line command and do that for the default float, and then copy that again and do it for the small float. And if you do this and you then open your command line, your terminal again, and you run this firstapp.go file, you'll see the difference. You'll see that for this default float, which is that float 64 value, which is this output here, we have a higher precision than for the small float. None of the two has this level of precision, but you typically also don't need that amount of precision for your calculations. If you would need it, you could convert it to an integer first and then do your math with that. But you definitely do see that we do have a higher precision for float 64 than for float 32. The latter is rounded and cut off earlier. And therefore, which kind of value you want to use, which kind of float you want to use, depends on the operation you'll perform. If you only need 2 or 3 or 4 digits of precision, you can go with float 32 and use up less memory. If you need a higher precision, you can go for float 64. Now, as I said, when you use that shortcut for creating a variable with := sign, very often float 64 will be chosen, and you could argue that this is suboptimal since it will take up more space in memory, but for many programs this won't really matter too much, and it's then more convenient to have this higher precision. It can also be quicker on some systems. If you need that last bit of optimization and tweaking, then you could go for float 32 if you only need a limited amount of precision. For the moment, you should mostly be aware of the differences and understand why we do have these two different types of floats.